All right, everyone. Oh, let me back up a little bit. All right, now we begin. All right, this is elementary statistics. We're going to learn a whole bunch of stuff about statistics, and we are starting. So just kind of think about what we're going to do in chapter 1. Here it is. We're going to do an overview real quick of stats. Then we're going to talk about how we define different data. What does it mean to be non-numeric data, or we're dealing with numbers and not numbers? So that's 1.2. And then 1.3 is going to be how do we collect data or actually make an experiment design? How do we set up a study? All right, let's go with it here. So 1.1 is where we're looking at. And let's go with definition. Definition of stats here, or just objectives here. Real quick, let's get to the definition. There it is. But first, before we get to the definition of statistics, how about we look at the definition of data itself? Data is just information, information coming from observations, observe something, whether it be a how fast a tree is growing, that's an observation, or a behavior of kids on a playground, that's observation, counts and measurements and responses. And so we look at that. Responses usually are just surveys. All right, with that done, let's jam to the definition here. So stats is about the science of collecting all that data, eventually organizing all that data, analyzing all that data, and then interpreting the data in order to make a decision. And so we're going to do a lot of data collection and finding out if that is true or false, or we can rely on that or not. And then whether it's useful, whether it's an outlier. So a lot of analyzing of data. All right. So first things first is that one major difference here of data sets is something called population. And population is the collection of all the responses, all the measurements of that interest. So if you were looking at the salaries of all the US population, that would be it right there. Then we have something called a sample. Sample is a subset or a part of that population. And that's a lot of times in stats, that was what we do here. We are not going to get all the people, but we can get a sampling of people, and that's done quite a bit. In terms of school here, so population, maybe a good example would be if a person at the district office or at the admin office, what it is, they ran all the GPAs of all the students. That would be a population. Sample idea would be, the cafeteria. Cafeteria, what happens once a year is that the director of the cafeteria, what they'll do is they will do a survey of whether you like the food or not. And what he'll do, he'll just kind of walk around the he walks around the cafeteria, and he'll just randomly draw a survey and asks people to fill it up, and that would be a sample, because he's not getting everybody in the cafeteria, just a sample. All right, let's jam with it then. So identify the data sets. Here it is. In a recent survey, 835 employees in the United States were asked if they thought their jobs were highly stressful. Out of the 834 respondents, 517 said yes. Okay, let's go with it. Identify the population. Who are we interested in? What are we trying to do? What is this all about? Yes, it is about whether the employees in the US are stressed about their job. So the population would be all employees in the US. That would be the population. The sample would be the 834 employees that we surveyed. So that would be the survey. Way small respondent base there. Okay, and then describe the sample set. So Sample sets are more like this here. Here's your sample of employees, and you're thinking about, you're trying to make inferences on the rest of the population. Right. And so he made up a sample set, and then we found out we have 517 yeses and 317 nos. Now the question is that true for the rest of the US population or the US employees in the US? So that's kind of what we're thinking about. Okay, let's jam. Let's look at the way we talk, some vocabulary here. So something called a parameter. Parameter is going to be some kind of numerical description of the population, something about the population. So it's the, like I said right here, average age of all people in the US. That would be a parameter. Or would say the GPA of West Hills College students. If we ran all the numbers and we figured out all the GPAs and we divided it. So it'd be the average GPA of a West Coast College student. The other one is called a statistic. Statistic is the description, some kind of numerical description of a sample. So let's say we went to 3 different states, because that's where our headquarters of our statistics was, and we surveyed those, and then we just made inferences to them, which kind of makes me kind of wonder, you know, whether different states in the US, if there's really a difference in age between people in the US, you know, is like Montana, you know, are there older people in Montana compared to California? You know, that's kind of interesting. I wonder if we can get stats on that. Okay, so let's go with just a quick exercise here. Decide whether each number describes a population parameter, or is it talking about a sample statistic? So think about this here. Is it talking about the whole entire population? Did we just get data? Did we get numbers? And we've got to figure out what the numbers all about. But did we get numbers for the entire population? Or did we get numbers for a sample? So a survey of 100 collegiate student athletes in the US found that during the season of their sport, the average time spent on athletics by student athletes is 50 hours per week. All right, let's jam with it here. So a survey was went out to 100 collegiate athletes. So population would be all the college athletes in the United States. But what we did is we actually did a survey of only 100 of them. So that means this has to be a sample statistic. And what is it? It's the fact that the student athletes spend 50 hours per week in their sport. And that's the sample statistic. So because the average of 50 hours per week is based upon a subset of the population, it is a sample statistic. Okay, one more. How about this one? Decide whether the numerical value, whatever that number is it describing a population or is it describing a sample? Freshman class. The freshman class at a university has an average SAT math score of 514. So then the question is, what's the population here? What are we trying to get to? The population is freshmen at a university, right? It didn't say anything about trying to figure out all the freshmen in the US. There was nothing about that. It was just the freshman class at this particular university. So the sample is, hey, the sample is the freshman class at the university. So hold on, we really are talking about the population. And so someone looked at the SAT scores of all the freshmen in a database, ran the numbers, and got an average of 415. This guy is a population parameter. Okay, one more. Right here, how about this? Decide whether this is a population parameter stat. Sample stat here, let's see, the 34%. 34% is describing so in a random check of several hundred retail stores, the Food and Drug Administration found that 34% of the stores were not storing fish at the proper temperature. So did the Food and Drug Administration look at every single store in the US? Nope. They did a random check of several hundred. Okay, right away, that's a sample statistic. That 34% is describing a sample statistic. Okay, there it is. That's important there to note, that one big distinction versus population versus sample. One other big distinction in statistics is this whole concept right here. Here's the two branches of mathematics or of statistics we're going to be doing. Something called descriptive statistics. And we are just trying to organize the data. We're trying to summarize the data, and we're trying to display the data. That's what that is. And in fact, if you want to turn to the contents of your stats book, 1 and 2, chapters 1 and 2 are descriptive statistics. And then we have chapters 3, 4, and 5 in your book, and that's called probability. It's something a little bit more similar to descriptive statistics, just takes it a little bit beyond that. All right, and then the other split here is chapter 6, 7, 8, 9, and 10. That's called inferential stats, and we'll get there. Once we are able to really describe the data, organize the data, then we're gonna go and start looking about drawing in some inferences or conclusions about the population. So get a sample, and then we're gonna infer about the population. All right, let's jam. Some examples real quickly here. So you tell me here. Identify the population and the sample, then determine which part of study represents the descriptive branch of statistics. So a study of 2,560 US adults found that adults not using the internet, 23% of them household earn less than $30,000 annually, as shown in the figure. So that's the little caption there. So identify the population. Population would be all US adults. The sample is going to be the 2,560 US adults that we surveyed or we got some data from. And so that means that 23% right here, is that a parameter or a sample statistic? It has to be a sample statistic here. All right, and what is this describing? The first part, describing this whole concept of the study, and that from the study, 23% of the household earning less than $30,000 annually. That part is the descriptive statistics. A possible inference, let me do this here. A possible inference is that lower income households can't afford, or for some reason or another, do not have internet. Or so there's an inference to the population then. So notice the descriptive statistics actually lay the groundwork for the inferential statistics. Okay, another one here. How about this? We're going to identify the population, identify the sample, determine which part of the study represents the branch, descriptive branch of statistics, and then what conclusion can we draw using inferential stats. So a study of 300 Wall Street analysts found that the percentage who incorrectly forecasted high-tech earnings in the recent year was 44%. Okay, let's go with it. And what is the population? Population is all Wall Street analysts ever. The sample was the 300 Wall Street analysts that they were able to get data from. And then that's the descriptive statistic. The descriptive statistic is the fact that they forecasted high-tech earnings in recent years was 44. So 44 of them were wrong in what they stated here. Inferential statistics. What can we draw from here? Possibly that the stock market is pretty difficult to analyze. Possibly that the majority of Wall Street analysts are able to forecast correctly. That's another one. That's a positive statement on that. So that's a whole bunch of different things here. So possible inference drawn from the study is that the stock market is difficult to forecast even for professionals. And I'm not sure is 44 a big thing or not. So anyways, that is the end. That is the end of 1.1. Now the next video shows 1.2 and 1.3.